In this sample problem, we are asked to balance the reaction of aqueous lead-4 chloride and silver nitrate to produce a lead-4 nitrate solution with a silver chloride precipitate. So here we have two compounds reacting to form two other compounds. We're going to start it off the exact same way that we did before. Okay, we know that we have lead-4 chloride reacting. Remember, the Roman numeral 4 means the lead has a 4+ charge. So we have PbCl4 aqueous reacting with silver nitrate. Silver has a charge of +1, nitrate has a charge of -1, so that's AgNO3. Don't write the charges in. It is also aqueous. They are reacting to form lead-4 nitrate. We see this as a solution, so it will be aqueous as well. Pb bracket NO3 bracket 4. And we also have a silver chloride precipitate. And that will be solid. We're going to set this up in pretty much the exact same way. So I'm going to break down my page into 3 sections. That first section's okay if it's super tiny. I see that I have lead, I have chloride, and remember that we're just looking at the chlorine atoms here. It's not going to be Cl4 altogether. It's just going to be Cl. I have silver, and then I can do something useful with the nitrates. Lots of people will break this up into nitrogen and oxygen. But if you look at our reaction here, we have NO3 on this side, and we also have NO3 on our product side too. So the number of nitrogens and oxygens are staying consistent relative to each other. So what you can do instead is you can balance the entire polyatomic ion rather than trying to split it apart into its component atoms. This reduces the number of variables you're working with. It reduces the amount of math you have to do, so it makes your life a lot easier if you do it this way. We're only doing this with the NO3 though. Those chlorines are each going to go independently of each other. So we're going to keep them separate and keep the nitrates together. So I'm going to count up how many of each I have in the reactants and then in the products. I have 1 lead, I have 4 chlorines, I have 1 silver, and I have 1 nitrate in my reactants. In my products, I have 1 lead, I have 1 chlorine, I have 1 silver, and I have 4 nitrates. Now, you'll notice the order in the product side is different than the order in the reactant side. That's okay. As long as everything stays in the same order down below, we're gravy. Next thing I'm going to do is I'm going to pick something to start balancing. In this problem, it doesn't matter where you start. So I see that my chlorines are unbalanced. I'm going to start with them. I have a 4 and a 1. I need to multiply 1 by 4 in order to bring it up to 4. Remember, most of the time, we're just going to use multiplication here. So I'm going to multiply that by 4. It becomes 4 down below. That means I need to put a 4 up top as well. When I change the 4 up top, whatever I do to the chlorine, I have to also do to the silver. So I need to multiply by the silver by 4 too. That brings it up to 4 as well. Now my silver's unbalanced, so I'm going to go to my other side. I have to multiply it by 4. Whatever I do down below, I also have to do up top. Whatever I do to the silver, I also have to do to the nitrate because they're part of the same compound. So I'm going to multiply my nitrate by 4 as well. But this time, I don't have to do anything else because what's happened here? What we see is that the number of nitrates has automatically balanced itself out. So when I do this balancing, I'm just bouncing back and forth until everything is balanced. And eventually, I'll come to the point where everything just clicks. So this one's nice and easy, especially if you do that trick where you keep this nitrate down here all as one group, because it's going to cut down on the amount of math you have to do.